In this concept, we're going to talk about graphing linear inequalities. So linear inequalities are graphed the same way as linear equations, but instead we take into account the inequality symbol, right? Which allows us to shade one of the regions or the other about the line that we get, okay? And we'll see what this means shortly. So the graph which is graphed on the plane is called the boundary of the region. Let's look at what this means. So for inequalities, you can either have them with the less than or equal or greater than or equal sign, or with just the less than or greater than sign. Okay, if the inequality symbol has the equal sign with it, then you would have to graph a solid line, okay, to indicate the boundary, right? Because the boundary is included, right? If it's equal, if both sides of the inequality are equal, less than or equal or greater than or equal. If the inequalities do not have the equal component, right, if they're just less than or just greater than, then you would graph a dashed line to indicate the boundary, right, just like here and here. So since this one has the equal sign, you indicate the boundary with a solid line. Here, since it doesn't have the equal sign, you indicate the boundary with a dashed line. Okay, very straightforward. So the main technique is that you would end up converting the inequality to the equation of a line, right? So you just treat it as if you were graphing a line. So determine whether the boundary line should be solid or dashed, and you could determine that by, again, just looking at the inequality symbol. This is very straightforward. So if it's greater than or equal or less than or equal, then it's solid. If it's just less than or greater than, then it's dashed. Once you've determined this, you graph the boundary line, and again, you can very easily do this by taking the inequality and just, basically just treat it as if you were graphing a line, right? So as if you were just graphing the line y equals 2x plus 2, right? In fact, this line is the line y equals 2x plus 2, right? And then after graphing the boundary line, choose a point that is not on the boundary, right, that is not on the line, and test it in the inequality. So for example, for this line, you would choose like the origin, for example. Let's say you don't have the shaded region determined yet. You would choose the origin because it's simpler, right? So if you just plug in to the inequality and see if it's true or not. If it's true, then you take the side of the point that you chose and shade it. So in this case, if you put the origin here, so 2 times 0 is 0, and then 0 for y is 0, 0 plus 2 is 2. Is 2 greater than or equal to 0? Yes. So you get a true inequality, so you would shade the region where you took the point from, which happens to be this region, not the other region. Right? So again, if a true inequality results based on the point that you chose that is not on the boundary, right? You choose either one, but typically the origin is very straightforward, right? 0 and 0. So if a true inequality results, shade the region containing the test point. If a false inequality results, shade the other region. Okay, very straightforward. Let's look at an example. Graph 6x plus 3y greater than 9. So first, like I mentioned, we treat the inequality as if it were the equation of a line, right? So we just take 6x plus 3y equals 9. So graph this line. And then, so right off the bat, we know that this does not have an equals component in the inequality symbol. So this is going to be a dashed line, right? The line is going to be dashed. And then the quickest way to graph this line is by finding the intercepts, right? So to find the x-intercept, we set y equal to 0, so then we have 6x equals 9, so x is equal to 3/2, right? 9 over 6, or 3 halves, or 1.5. So this is the x-intercept, okay? And likewise, determine the y-intercept, right? So to do that, we set x equals 0, so we have 3y equals 9, so y equals 3. So the y-intercept is 0 and 3. Then we place the intercepts on the coordinate plane, so 1.5 and 0 for the x-intercept, and then 0 and 3 for the y-intercept. And we did say the line was going to be dashed, so we graph a dashed line. Okay. Then we can choose a test point, right? And again, let it be the origin because it's straightforward. Obviously, we do connect the intercepts and, create the dashed line. After that, we select a test point, and again, that being the origin because it's simplest. So then 6x plus 3y is greater than 9. This is our inequality. Plug in the origin coordinates, 0 and 0. So 0 plus 0 plus 0 is 0. Is 0 greater than 9? No, it's not. Therefore, we will take the region on the other side of the line, not the region containing our test point, right? So we don't take this region, we'll take this region, okay? So the answer is that this will be the shaded region, and this will be the boundary line, and the boundary line will be dashed, not solid. Okay? And here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so we need to graph the following inequalities. 2x minus 3y less than or equal 1. Again, just follow the standard procedure, right? So first, treat it as if it were the equation of a line. So just convert the inequality sign to an equal sign. Then find the x and y intercepts of said line. So the x-intercept is, we convert the y to, we put in y equals 0. So we have 2x equals 1, which gives x equals 1/2. So the x-intercept is 1/2 and 0. For the y-intercept, we treat x as 0, right? So 2x goes away. So then we have minus 3y equals 1. So y equals minus 1 over 3. So the y-intercept is 0 and minus 1 over 3. Okay, and then what we do is we graph the we graph the line by plotting the intercepts. So 1, 2, etc. 1, 2, 1, 2, 1, 2, right? So 1/2 and 0, this is x-intercept. Minus 1/3 and 0, y-intercept, right? And then the inequality sign has an equal component, so this will be a solid line. So just graph the solid line. And again, this just keeps extending. Then we can use a test point, right? And again, let it be the origin, 0 and 0. If we plug in 0 and 0, so we get 2 times 0 is 0 minus 0 less than or equal to 1. So is 0 less than or equal to 1? Yes. Okay. Therefore, we shade the region that does contain the test point, right? So this is the answer to the inequality. Whoops. Yeah. Here we go. Okay. Next exercise. 1/2 x minus 3/4 y greater than 5/4. So So again, we convert it to the equation of a line, or basically just convert the inequality sign to an equal sign, and then just finding the intercepts. X-intercept is setting y equal to 0, which gives us half x equals 5/4. So x is equal to 1/2, right? We multiply by 2, multiply by 2, right? So these cancel, and 2 and 4, 2, 5/2. 5/2. Okay, so then the x-intercept is 5/2, 5/2 and 0. For the y-intercept, we set the x equal to 0, so we have -3/4 y equals 5/4. So then that gives us, we multiply by -4/3, right? So that gives us -5/3. Y equals -5/3. Right? So the intercept is 0 and -5/3. Okay? So then we look at the inequality sign, and there's no equal component in it, so the boundary will be dashed, right? And then we just create a coordinate plane, 1, 2, 1, 2, 1, 2, 1, 2, right? So the x-intercept is 5/2 and 0. 5/2 is 2.5, so somewhere here. The y-intercept is 0 and -5/3, so 5 divided by 3 is about 1.66, etc. So here, 0 and -5/3. Okay, and then it's a dashed line, so we connect them with a dashed line. Okay, and then we choose a test point, and again, origin is the simplest. So if we plug in 0 and 0 to the main equation, right, we'll get 0 minus 0 greater than or equal to 5/4. So is 0 greater than 5/4? And the answer is no, right? So we end up taking the opposite region. So not the region that has the origin, but the opposite region on the other side of our inequality boundary line, right? Which is this region. So we end up shading this region. Okay? And this is it for this concept. See you in the next video.